for you. Let's move on to the next one, email threats. What actually an email threat? As per then RFC 4686, which describes the threat being addressed by the domain keys identified mail in terms of characteristics, capabilities, and locations of the potential attackers. Let's see one by one actually. So which describes the problem, as I said that. So the characteristics nothing but the range. It may be a low end, a spammer, or a frauds. And second one, capabilities in terms of where submitted or signed or volume or routing name, etc., and which is the location outside located attackers. Let's see or discuss one by one. The first one, and under the email threat characteristics. This characteristics has been defined in RFC 4686, the range of attackers on a spectrum of 3 level of the threat. The first one is something but at the low end. At the low end are attackers who simply want to send email that a recipient does not want to receive. The attacker can use one of the number of commercial available tool that allows the sender to falsify the origin address of the message. This makes it difficult for the receiver to filter spam on the basis of originating address or domain. The next one, at the next level. At the next level are professional senders of bulk spam mail. These attackers often operate commercial enterprises and sends message on behalf of third party. They employ more comprehensive tool for attack, including mail transfer agents (MTAs) and registered domains and networks of comprised computers, zombies, etc., to send some and in some cases to harvest address to which to send. The third one, the most sophisticated and financially motivated sender of users, which are those who stands to receive a sustainable financial benefit, such as from an email-based fraud scheme. The attacker can be expect to employ all of the above mechanisms and additionally may attack the internet infrastructure itself, including an domain name system, DNS, cache positioning attack, and IP routing attacks. These are the 3 characteristics of an email threat. Next, move on to the capabilities of the email threat. Under RFC 4686, almost some 11 capabilities that have been attacker might have. The first one, submit message. Submit message to MTAs and message submission agent at multiple locations in the internet. Construct attributory message header file, which includes those claiming to be mailing list, resender, and other mail agents. Third one, signed message on behalf of domains under their control can be signed on this one. The fourth one, generate sustainable numbers. Generate sustainable numbers or either unsigned or apparently signed messages that might be used to attempt a denial of service attack. The fifth one, resend message. Resend message that may have been previously signed by the domain. The sixth one, transmit message, which using any envelope information which have been desired. Seventh one, act as an authorized submitter for message. Act as an authorized submitter for message from a comprised computer that can be possible. Then manipulation of IP routing. This could be used to submit messages from specific IP addresses or difficult to trace addresses, or to cause diversion of message to a specific domain. Limited influence over portion of DNS, which using the mechanisms such as cache positioning, this might be used to influence message routing or to falsify advertisements on DNS based key or signing practices. Access to significant computing resources, for example, through the conscription of worm infected zombie computers. This could allow the bad actor to perform various types of brute force attacks. The last one, ability to eavesdrop on existing traffic. or perhaps from a wireless network. So these are the 11 capabilities of the email threat. Let's move on to the location. DKIM focuses primarily on attackers located outside the administrative unit of the claimed originator and the receptant. These administrative units frequently corresponds to the protection portion of the network adjacent to the originator and receptant. It is in this area that the true relationship required for authenticated message submission do not exist and do not scale adequately to be practical. Conversely, within this administrative units, there are other mechanisms such as authenticated message submission that are easier to deploy and more likely to be used than DKIM. External bad sectors are usually attempting to exploit the any-to-any nature of email that motivates most receptant MTAs to accept messages from anywhere from delivery to their local domains. Sometimes they may generate messages without signature, with incorrect signature, or with correct signature from domains with little traceability. They may also possess a mailing list, greeting cards, or other agent that legitimately send or resend message on behalf of the other. These are the four ways of the locations are going to be identified in the email thread. Next, we will move on to the DKIM strategy. So DKIM is designed to provide an email authentication technique that is transparent to the end user. In essence, an user's email message is signed by a private key of the administrative domain for which the email originated. The signature covers all of the content of the message and some of the RFC's 5322 message headers. At the receiving end, the MDA can access the corresponding public key via a DNS domain name system and verify the signature, thus authenticating that the message comes from the client administrative domain. Thus, a mail that originates from somewhere else but claims to come from a given domain without pass the authentication test and can be rejected. This approach differs from an SMIME and PGP, which use originator's private key to sign the content of the message. The motivation for DKIM is based on the following reasons. Let's see about the reasons. The simple the secure MIME depends on both the sender and receiver users employing an SMIME. For almost all users, the bulk of incoming mail does not use SMIME, and the bulk of the mail the user wants to send it to recipient not using secure MIME. The secure MIME signs only the message content, thus RFC 5322 header information concerning origin can be comprised. The DKIM is not implemented in the client program, that is MUAs, and is therefore transparent to the user. So the user need take no action. The DKIM applies to all mail from cooperating domains. And the fifth one, DKIM allows a good sender to prove that they did send a particular message and to prevent forgers from masquerading a good sender. Let's discuss about this DKIM strategy with an example.